Before we dive in, let's do a quick activity. Can you recognize the names of these scientists based on their contributions to science? From these scientists, one of them came up with the equation E equals mc squared, another has 3 laws of motion and universal gravitation named after him, and another made significant contributions to astronomy and improved the design of the telescope. Now, let's switch gears here. Of these scientists, which ones can you recognize? One of them was the first computer programmer and revolutionized the trajectory of the computer industry. Another one of them produced the world's first comprehensive map of the entire ocean floor. And another classified over 350,000 stars manually and revolutionized the way scientists classify stars to this day. And if you can't recognize these scientists, you're not alone. In fact, this was my story. My name is Priyam, and I'm currently an undergraduate in university studying molecular cell biology, concentrating in immunology and molecular medicine. But let's go back to the first chapter when this all started. Since elementary school itself, I was an avid science enthusiast, constantly involved in STEM activities from first joining robotics in 2nd grade to now working on cancer gene therapy research in my college years. But in my middle school years, I found myself preparing for an upcoming Science Olympiad competition. But as I was going through this incredibly large textbook to study for the genetics event, I noticed that there was only one mention of a scientist that was a woman. At first, I genuinely believed that it was because there weren't that many women in science throughout history to begin with, and very quickly I found out this really wasn't the case. In fact, a study showed how 145 women scientists were mentioned, compared with 962 male scientists across 7 biology textbooks, according to a 2020 study in the Royal Society Publishing Journal. Moreover, such disparities are consistent across other STEM disciplines and range across other demographics as well. In fact, one study showed a similar statistic and demonstrated how, on average, people of color appear every 320 pages of text, while white figures are observed every 24 pages across 10 U.S. college STEM textbooks published between 2016 to 2020. So, why exactly is this an issue? Well, not only are we leaving out individuals from history who have done incredible feats in the past, but we are preventing ourselves from shaping the scientists of the future. One of the key factors that contribute to a student's success in the classroom is a sense of belonging. Think about a time when you felt a spark or a connection in the classroom and realized, wow, I really enjoy this, or wow, I'm really good at this. How did this spark come about in the first place? It's because in that moment you felt as if you belonged, and it ties to an actual psychological phenomenon in education called the self-reference effect. The self-reference effect states that when we have the ability to not just learn about a concept, but actually explore and relate to a learned concept, we allow students to remember lessons a lot more effectively and therefore get students to become more engaged and excited with what they learn. Now, going back to disparities found in textbooks and curriculum, how does a sense of belonging specifically tie into this? Well, what we learn in a classroom, especially from a young age, heavily promotes and shapes a student's personality development throughout one's youth. And it is through education that students mold their unique sense of identity, further shaping the perception of not just themselves, but others around them from a very young age. However, if our educational curricula continues to promote a narrow image of the individuals who contributed to science, we further reduce the sense of belonging in STEM classrooms and the overall retention rates in STEM programs and eventually careers going forward. And, of course, applied and technical learning is fundamental in teaching science, but engaging in scientific history is just as important for contextualization of how these discoveries were made in the first place, as backed up by a Boston University article titled, "Why Scientists Need History Lessons." So, what's the solution? Well, the first step is to simply recognize and acknowledge the fact that bias continues to exist. Whether this be in the form of linguistic biases or the actual lack of citation of scientists who have contributed to a certain area, The step of recognizing and acknowledging these biases come from including the voices of numerous individuals when it comes to designing and implementing educational curricula. This can be through the form, for example, of having a board of individuals from a wide variety of backgrounds to take part in the revision process of editing a textbook or curricula before it gets published into the real world. Which leads us to the next step, actively reflecting on the curricula that we use to educate from, both as students and as educators, and communicating such reflections to curriculum developers and school districts. By doing so, we can develop strategies on how we can improve the overall sense of belonging in STEM classrooms through educational material. Now, let's go back to those 3 scientists I showed at the very beginning of this talk, and let's give them their deserved recognition. First, we have Ada Lovelace, history's first computer programmer and pioneer of modern computer science. Next, we have Mary Tharp, the first person to publish a complete world map of the ocean floor to prove the theory of plate tectonics. And last, we have Annie Jump Cannon, who developed the system we still use to this day to classify stars based on temperature. So together, let's reimagine a future where individuals, regardless of their background, are recognized, while also inspiring the next generation of scientists and change makers, therefore writing a new chapter in this story. Thank you very much.